Now in this video, I want to show you how we can calculate, how we can find the electron current. We know by definition the electron current is the number of electrons that flow per unit time. And I will show you how we can calculate that. If I know that the mobile electron C, the transparent red thing that I have here, if this thing moves to the right, let's say the electrons move to the right, then in time delta t, then this thing, the mobile electron C, will shift to the right by what amount? This length, the shift, is going to be equal to the speed of the mobile electron C times delta t. Remember, speed equals distance over time. And if you want to solve for the distance, just multiply the speed with time. So I'm using the speed of the mobile electron C, and I am multiplying it with the time. This will give me this length. Now, because this is a 3D object, the wire is a 3D object. If I know what is the area of the wire, let's say you take the wire and you cut it, and then you can see the circle. If you know that area, then I can multiply. Let me show you here. If I multiply the area times that length, okay, the length times the area will give me the volume. By how much volume the mobile electron C has shifted to the right. And I can show you using this. The product A times the speed times delta t will show me what is this volume. Now, electrons, the electron current is defined as the number of electrons that go by in time delta t. Now, what this will give me, this product here will give me the volume. There is a concept that we call the electron density, that is telling us essentially how many electrons, the number of electrons that we have in a unit volume. So it's the number of electrons, let's say, per meters cubed. This will be the units. That means if the electron density shows me how many electrons I have in a unit volume, if I multiply the electron density with the volume, I'm gonna get the number of electrons, which is in the numerator. So that's what I'm gonna do. I'm gonna take the electron density, eta, the Greek letter eta, and I will multiply it with the volume. And I'm still dividing with delta t. This has to be divided by time by the definition of the electron current. Now, the electron density times the volume will give me the number of electrons, which is what I need. But I know that the volume can be calculated as the area times the speed times delta t. And now I can make the two delta t's go away. And the expression that I get for the electron current is the electron density times the area of the wire times the speed of the mobile electron C. Okay, so this is an expression that you can use to calculate the electron current. It is possible also to do one approximation for the speed of the electron C. let's see, do we have space? So let's say here I'm gonna write the same thing, n eta times the area times the speed. There are if what you have for your system, for your conductor, is the mobility, and if I remember correctly, for mobility we use the Greek letter mi and the electric field. You can find the speed by taking the product of the mobility times the strength of the electric field inside the wire. So let me remind you, this here is the electron density. The Greek letter mi here, this is the mobility. And the magnitude of E, it just refers to the strength of the electric field inside. Now, what this means is that the stronger the electric field you have inside the wire, the faster your mobile electrons are going to move, which makes sense. If you increase the electric field inside, you increase the electric force, and it makes sense that they will start moving faster.